Welcome back. In the last lecture, I talked about financial swaps. I also touched upon the concept of forward rate agreements. These are special types of swaps in which we exchange only one set of cash flows. One party pays a fixed rate cash flow on a fixed interest rate cash flow, the other party pays a floating interest rate cash flow. Swaps are more general in nature in the sense that they involve a series of cash flows. Then we also talked about the valuation of forward rate agreements, and we also talked about various properties of swaps in the sense that why the swaps have become so popular, what are the nuances attached to swaps, how do we explain the popularity of swaps, and how do we explain the existence of differentials in the fixed rate market vis-a-vis the floating rate market for a pair of entities, the theory of comparative advantage, and we also discussed the criticism of the theory of comparative advantage. And then we moved on to the primary issue of valuation of swaps, that is from where we will take up today. We started talking about the valuation of a floating rate bond. Now, what is a floating rate bond? A floating rate bond is a bond on which the interest rate payment is fixed at the beginning of each period to which it relates. That period may be a 6 monthly period, period may be an annual period, is usually at 6 monthly period. So, at the beginning of every 6 month period, the interest rate is fixed on the basis of the market rate that is prevailing at that point in time, usually the LIBOR, or it may be some other variant, it can be the prime rate also, but the or the treasury bill rate for that matter. Whatever it is a certain benchmark rate, and the interest rate on the floating rate bond is fixed in line or as a function of that particular benchmark rate, and it applies to the interest payment that is to occur at the end of 6 months from that particular date. And we argued that if the value of a floating rate bond would be its par value at t equal to 0 at the on the date on which it is issued. Let us examine this case up a little bit further. Let us consider a floating rate bond of the face value of 100. It has one remaining annual interest payment. The interest rate is fixed at t equal to 0, that is today, for the payment that is to be made at the end of 1 year. For simplicity, I am assuming that the interest payment is made annually. Let us assume that the LIBOR as of today is 5%, and therefore, the interest rate on the bond is tagged to 5%, and as a result of which a payment of 105 units of money will be received at t equal to 1 on the basis of the interest rate that is fixed at t equal to 0. It will comprise of 100 rupees or 100 units of money of the principal, the face value, and 5 rupees for the interest. So, what would be the intrinsic value of the bond as of today? It would be the present value of this cash payment of 105 rupees discounted at the current rate, which is 5%, that comes to 100 precisely. So, the inference is quite clear that if the interest rate is fixed in accordance with the benchmark rate, and the discounting is also done as per the benchmark rate, we end up with the par value of the bond. And this is this also, for the finance behind it is that if the required return is equal to the return provided by the instrument, or the expected return by the investor community is equal to the return provided by the instrument, then the instrument would be quoted at par value. Let us take a slightly more involved example. Now, we consider a bond which is 2 years to maturity. It will mature at t equal to 2, there will be a coupon payment at t equal to 1, there will be a coupon payment at t equal to 2, and there will be a principal redemption at t equal to 2 at the end of 2 years, that is. So, now how do we can obviously set the rate at t equal to 0 for the period 0 to 1, because we know that rate as of today, the market rate prevailing or the LIBOR that is prevailing as of today will enable us to set the floating rate for the period 0 to 1 on the basis of which the coupon payment will be made at t equal to 1. But what about the coupon payment at t equal to 2? We do not know the rate which prevails at t equal to 1. In fact, it is a random variable. So, that is why, that is in fact the reason why this bond is called a floating rate bond, because the interest rate would, to be fixed at t equal to 1 would depend on the market rate that would prevail at that point in time. However, we can have a proxy for that, and how do we create that proxy is by using the principle of no arbitrage. Using the spot rates or the market rates for the maturity of t equal to 1 and the LIBOR rate for maturity of t equal to 1, the LIBOR rate for maturity of t equal to 2, we can work out the forward rate for the period between t equal to 1 and 2, which can serve as a proxy for the LIBOR that is expected to arise at t equal to 1, and that will apply for the period from t equal to 1 to t equal to 2. In other words, what I am simply trying to say is that in the absence of, because the interest rate at t equal to 1 is random, we do not know it at t equal to 0, we can use the forward rate for t equal to 1 for t equal to 1 to t equal to 2 as a proxy for that particular market rate at t equal to 1. Obviously, as time passes, this forward rate may also change, but this rate at t equal to 1 is known because of the spot rates at known at for t equal to 0 to 1 and t equal to 0 to 2, and the satisfaction of no arbitrage condition. This is the condition for no arbitrage. F 02 whole square is equal to F 01 plus 1 plus S 02 whole square is equal to 1 plus S 01 into 1 plus F 12. F 12 is the forward rate between 1 and 2. S 02 is the spot rate for a maturity of 2 years, annual rate for a maturity of 2 years, and S 01 is the annual rate for a maturity of 1 year. So, on that basis we work out the, or we can use the forward rate, or we can work out the forward rate F 12. And let us calculate the value of the bond. Let us calculate the value of the bond on the premise that at t equal to 1, the rate that turns out to be the LIBOR at t equal to 1, and that therefore is the floating rate that is fixed at t equal to 1 to apply for t equal to 1 to t equal to 2 is the forward rate that we have worked out at t equal to 0. In other words, we believe, or we make the assumption that the forward rate F 12 is actually realized. So, if that is so, then the cash flows would be on this 2 year bond would be, if F is the face value, F into S 01 for at t equal to 1, this is the coupon payment at t equal to 1, and then at t equal to 2, there will be the coupon payment at F into small f 12, where small f 12 is the forward rate, which would be the rate applying to 1 to 2, plus the redemption of face value is capital F. And this first coupon payment would be discounted at the spot rate that is prevailing at this point in time, t equal to 0, that is S 01, and the second cash flow that is at t equal to 2 will be discounted at the spot rate with a maturity of 2 years, which is F S 02, and therefore, because it is a discounting for 2 years, it has to be squared, right. So, the first coupon payment is discounted at S 01, which is the spot rate for a maturity of 1 year, and the second coupon payment and the redemption of principal is discounted at the rate S 02, which is the spot rate for a maturity of 2 years. You simplify this expression, the second expression you simplify, and if you use this no arbitrage condition, you end up with the expression F. Therefore, if the forward rate that we have worked out turns out to be actually realized, in other words, this is the rate at which the second coupon is paid, and that would be if the floating rate at t equal to 1 is fixed to be F 12, then the present value of the bond or the intrinsic value of the bond will work out to its face value once again. Right. So, this is an example of what I have just explained. Let S 01, that is the spot rate for a 1 year maturity, be 5%, the spot rate for a 2 year maturity be 6%, then the forward rate for the period 1 to 2 t equal to 1 to t equal to 2 turns out to be 7.0095%. And therefore, LIBOR at t equal to 1, which applies for the period from 1 to 2, shall be fixed at 7.0095%. That is the assumption that we make in this model. So, the present value of the 2-year bond will be 5, that is the coupon payment at the end of the first year, which is made at 5%, which is the rate fixed at t equal to 0 for the period 0 to 1, divided by the rate that is prevailing as of today for a maturity of 1 year, that is again 5%, plus the coupon payment at the end of the second year will be at 7.0095% and the redemption of principal will also be there. So, the total cash flow will be 107.0095 and this redemption will be at the spot rate for a 2-year maturity, which happens to be 6%. You simplify this expression, you end up with 100, which is the par value of the bond. Now, let us do this example, which is an extension of what I have just explained. Consider a floating rate bond of the face value of 1000. Consider a floating rate bond of the face value of 1000 that pays 6 monthly floating rate interest indexed to 6 month LIBOR. So, this is a floating rate which is indexed to 6 month LIBOR, fixed in advance, paid in arrears. The interest rate is set at the beginning of the 6 month period, that is what I mentioned. The interest rate is set at the beginning of the period to which it relates. The actual payment takes place at the end of the period. The rate is fixed at the beginning of the period. The bond was issued 9 months ago and it has a remaining life of 4.25 years. That is, the life of the bond is 5 years. It was issued 9 months ago and it has a remaining life of 4.25 years. The last LIBOR was reset at 3 months from today, 3 months back. See, let me draw a short timeline. This is where we are today. This is 3 months back. This is the date of issue. So, this would be 6 months. This would be 3 months. This is t equal to 0, and this whole thing is 4.25 years. Right. So, this is 6 months. Backward. This is past. In fact. So, the last reset was made at this point, and this reset was made at 12%. So, the LIBOR applicable for the period from t equal to minus 3 months, that is 3 months ago to 3 months in the future, up to 3 months in the future. This is t equal to 3 months plus 3 months. This is plus 3 months, this is minus 3 months. You see, LIBOR setting is for a period of 6 months. So, since the last LIBOR was set 3 months ago, this LIBOR will hold for a period of 6 months. In other words, it will hold from t equal to minus 3 months to t equal to plus 3 months. This period of 6 months will be governed by this LIBOR of 12%. The current 3 month LIBOR means that today's LIBOR for a maturity of 3 months, that is for a maturity of this period, works out to 9% per annum with continuous compounding. Please note, this 12% per annum is compounded half yearly. So, we have to do nothing with the compounding part, because it is paid semi-annually and it is compounded half yearly also. So, there is no problem. The current 3 month LIBOR is 9% per annum continuous compounding. What is the value of the bond? So, the face value is 1000 rupees. The last LIBOR reset was 12%. This was set 3 months ago. I reiterate, it is 3 months ago and it holds for a period of 6 months. That means, it is set at t equal to minus 3 months and the payment in accordance with this 12% will be made at t equal to plus 3 months. Setting at t equal to minus 3 months and the actual payment at t equal to plus 3 months. So, what is the amount of this payment? 12% per annum. So, 12% per annum and the payment is half yearly. So, it comes to and it is compounded semi-annually. So, we do not have to play with it. It is 6% for the half year and 6% on 1000 is 60. So, the amount of 60 will be paid on account of interest at t equal to plus 3 months. Right. So, once this t equal to plus 3 months interest is paid, the next interest would be obviously paid at t equal to plus 9 months, but we are not concerned with that. Now, as soon as this bond at t equal to plus 3 months is stripped of this interest payment, it becomes a fresh bond on which interest is paid at the end of 6 months and interest is tagged to the LIBOR, and therefore, the value of the bond after payment of this interest, will be equal to its face value. Let me repeat, once this 60 rupees interest is 60 units of money interest is paid, then the next payment will occur at the end of 9 months and thereafter at the end of every 6 months. But the important thing is, now this bond behaves like a fresh bond that involves interest payment at the end of every 6 months, at the end of every 6 months, and the interest rate being tagged to the current market rate, which is the benchmark of which is taken as the LIBOR. So, that being the case, the value of the bond after this interest payment will be equal to its face value. Therefore, the total value of the bond at t equal to 3 months from now, t plus 3 months, that is, will be equal to 1000, the face value after the stripping of the interest plus the actual interest, that is 1060. 60 rupees is the actual interest that you have received, and once that 60 rupees of interest you have received, whatever remains is worth the face value, and that is 1000. So, the total value of the bond at t equal to 3 months is equal to 1060, and you bring it back or work out the present value at t equal to 0 using the current LIBOR rate of 9% continuous compounding, you end up with a value of 1036.42. So, this is quite straightforward. Now, we extend this further, we talk about valuation of a swap. Now, as you know, a swap can be valued in two different ways. One is you value it as a series of forward rate agreements, and the other is that you consider a swap as an exchange of a floating rate bond and a fixed rate bond, value the fixed rate bond, value the floating rate bond, take their difference, and that gives you the value of the swap. Both these methods I will illustrate by virtue of this example. Suppose that a financial institution has agreed to pay 6-month LIBOR, the FI is paying 6-month LIBOR and FI is receiving 8% semi-annually with semi-annual compounding. So, we do not have to worry about the rate. On a notional principle, this annual, in fact, this is 8% annually with semi-annual compounding. So, it is 4% for every half year period. This semi word should not be there. So, 8% annually with semi-annual compounding, that is 4% for every half year period on a notional principal of $100 million. The swap has a remaining life of 1.25 years. The LIBOR rates with continuous compounding for 3, 9 and 15 months are 10%, 10.5% and 11%. The 6-month LIBOR rate at the last payment date, which will apply for the next 6 months. When was the last payment date? Please note this, the bond has a remaining life of 1.25 years, right. So, that means the last payment date would have been 3 months ago, that is t equal to minus 3 months, and it would extend to t equal to plus 3 months, because it is a 6 monthly interest payment bond, and that rate has been fixed at, has been tagged at 10.2% per annum with semi-annual compounding. Calculate the swap's value. So, first I will illustrate this problem or the solution to this problem using the exchange of the fixed rate and the floating rate bonds, and then we will take we will solve the same problem using exchange of using a series of forward rate agreements. So, the financial institution is the floating rate payer. So, therefore, is the floating rate payee. So, from the perspective of the financial institution, it is receiving the fixed rate, it is paying the floating rate, and therefore, as far as the financial institution is concerned, the value of the swap to it is the value of the fixed leg that it is receiving, that it minus the value of the floating leg that it is paying. If you note, the financial institution is paying the floating rate and it is receiving fixed rate. So, as far as the financial institution is concerned, it is receiving the fixed rate. So, when it values the swap, it will ascribe a positive value to the fixed leg, and it will ascribe a negative value to the floating leg. Now, the floating leg valuation is relatively straightforward. We have cash flows of the rate is 8% per annum semi-annually compounded. So, that works out to 4% per annum, 4% for every half year period, and the principal is 100 million. The principal is 100 million. So, 4% for every half year, that means, and the next payment date, you see the remaining life of the instrument is 1.25 years, and payments are to be made every 6 months. So, working backwards, this is the first 6-month period, this is the second 6-month period, and therefore, this must be 0.25 years, and we are here today. This is t equal to 0 as of today. So, the next exchange of interest will take place at the end of 3 months from now, that is 0.25 years from now, and the last reset or the last setting of the LIBOR, which will apply to this period t equal to minus 3 months to t equal to plus 3 months will be was 10.4%, and this will apply for the period from t equal to minus 3 months to t equal to plus 3 months, but we will come back to it. For the moment, we are focusing on the fixed leg, and the fixed leg means a payment of 4 unit share or on account of $4 million here on account of the semi-annual fixed interest, 4 million here on account of semi-annual fixed interest, and then the principal repayment and the interest payment at the end of the life of the swap of 104. So, there will be 3 payments, t equal to 3 months, t equal to 9 months, and t equal to 15 months. That is what are being reflected in this column. T equal to 0.25, that is 3 months is 4, t equal to 0.75, that is 9 months is again 4, and t equal to 1.25, that is 15 months is 104. It includes the principal of 100 million, notional principal of 100 million. The discount factors are calculated at the respective rates which are given to us. Please keep in mind that these rates are continuous compounding rates. The rates are given at 10% for 3 months, 10.5% for 9 months, and 11% for 15 months. So, these discount rates are calculated at 10% for 3 months, 10.5% for 9 months, and 11% for 15 months. I reiterate, they are calculated on the basis of continuous compounding, and therefore, we arrive at the value of the total value of the fixed leg as 98.2378959. Now, let us look at the floating leg. This is more interesting. The interest rate which was fixed at t equal to minus 25 months, t is equal to minus 0.25 months, that is t equal to minus 3 months, for the period from t equal to minus 3 months to t equal to plus 3 months, t is equal to plus 3 months is given as 10.2% compounded semi-annually. So, that is 5.1% for the half year period. So, the cash flow on account of interest that will occur at t equal to plus 3 months works out to 5.1 million, that is 10.2% for the full year. So, 5.1 for the half year applied on a notional principal of 100 million. So, that is 5.1 is what you get on account of interest, but that will be paid at t equal to 3 months, and once that interest is stripped of the bond, whatever remains is the face value of the bond, because it is a floating rate bond, and discounting and compounding are both being done at the LIBOR rate. So, that being the case, the total cash flow attributed to the floating leg will be equal to the cash flow on account of interest at t equal to 3 months, that is 5.1, and the remaining residual value of the bond, which is equal to its face value. So, that is 100. So, the total cash flow is 105.10. This will be, now this is the value at t equal to 3 months. Please note this. This is the value at t equal to 3 months. What will the value be the value at t equal to 0? Because we have to value the swap at t equal to 0. So, we discount this, we bring it back to t equal to 0, work out its present value at the rate of 10%, which is given to us, and we find that the present value works out to 102.5050, and therefore, the net value works out to the value of the fixed leg minus value of the floating leg at t equal to 0, both of them, and that works out to minus 4.2671 from the, this is from the perspective of the financial institution, which is the floating rate payer, and it is paying more and it is receiving less. So, it is a negative value from the perspective of the financial institution. Let us do the same problem using the implicit forward rates. As I mentioned, we can assume, or we make the assumption here, that the rates that will be fixed in future for the swap on the floating side will be equal to the forward rates prevailing, or that can be worked out on the basis of no arbitrage conditions at t equal to 0. Let me quickly explain the process of working of the forward rate and before I get into the solution. Since we are using continuous compounding, what do we have? We have exponential r, this is my r for the first 3-month period, into the 3-month period exponential. Then this, you see, let me draw a timeline. This is 0, this is 3 months, and then this is 9 months. This is 3 months, this is 0. So, the no arbitrage condition requires that if I make a deposit at t equal to 0 for 3 months and then roll it over for another 6 months, the proceeds that I should get at t equal to 9 months must be equal to the proceeds that I would get from a direct deposit of 9 months. That is simply stated in the no arbitrage condition, of course, assuming that the risk remains unchanged, and that is an assumption that we are implicitly making. So, that being the case, we apply this to this analysis, and we get exponential this part, the first part, let us call it AB. AB gives me exponential S0, this is T0, this is T1 and this is T2. So, S, the interest rate which holds for T0 to T1, that is S T0 T1 into the period T1 minus T0 into exponential, now the second part, the part BC T1 to T2, the T1 to T2, and that gives me exponential forward rate from T1 to T2. We are assuming that the forward rate is known, or we want to work out that forward rate which follows from no arbitrage. Exponential f T1 to T2 into T2 minus T1, this period must be equal to the direct deposit from A to C, which is exponential S T0 to T2 into T2 minus T1. You simplify this expression, you get f0 to 0.25 to 0.75, that is this forward rate between B and C is equal to 10.50 into 0.75 minus 10.00 into 0.25 divided by 0.50, that comes to 10.75. So, this is how we work out the no arbitrage forward rate. Now, we have got the no arbitrage forward rate for the period from t equal to 3 months to t equal to 9 months. Now, the important thing now is that this rate, we worked out the whole thing on the basis of continuous compounding. So, this rate is also continuous compounding rate, but the swap payments are to be made on the basis of the semi-annual compounded rates. So, we have to convert this continuous compounded rates to semi-annual compounded rates, and that gives us a semi-annual compounded rates of 11.044%. How do we get this? Well, e to the power r is, let us say I have an amount of rupee 1 at t equal to 0 beginning of the year. The amount that I will have at the end of the year is e to the power r, where r let us call it RC, where RC is the rate, continuous compounding rate. If I use a semi-annual compounding rate, the same amount I should get. If y is the semi-annual compounding rate, then this expression should be the amount that I will get at the end of 1 year, 1 plus y by 2 whole square. And if the two rates are to be the same, if the two rates are to be equivalent, rather, the amount that I should get at the end of 1 year should be the same, and this is the expression that has to be solved for arriving at the relation between RC and y. We know RC, we need to work out y. That is precisely what I have done here, and I have arrived at 11.044%. So, now let us go back to this. For the payment at t equal to 3 months, there is no problem. The spot rate is 0.1%, forward rate because it's a payment that starts at t equal to 0, so there is no issue here. The floating payment is 5.1 as we saw just now. The fixed payment is 4 as at t equal to 3, that is the difference is 1.1. The discount factor at the rate of 10% is this much, and so at t equal to 3 months the issue of floating forward rate does not arise, because the rate has already been fixed at t equal to minus 3 months. So, both the rates are known at t equal to 0, at least for the payment at t equal to 3. So, there is no issue of working out any forward rate. But in the case of the next payment, which occurs at t equal to 9 months, what happens? The rate that we worked out, the forward rate that we worked out, or the rate that should apply for the period from t equal to 0.25 to t equal to 75 on the floating leg will be equal to 11.044%, that is we have just worked out. This is the forward rate, this is the floating rate that has been fixed at t equal to 0, that is deemed to be fixed, at t equal to 0.25, and to apply for the period from t equal to 0.25 to t equal to 0.75 on the floating leg, and on the fixed leg of course it remains the same. So, this is the difference cash flow that will arise at t equal to 9 months, and this is discounted at 10.5%, which is the 9-month LIBOR rate, continuous compounding. And for the next cash flow, which is going to arise at t equal to 15 months, we work out the forward rate in a similar manner, and we arrive at 12.102%. 12.102% is the forward rate that is going to apply from t equal to 9 months, that is t equal to 0.75 to t equal to 1.25. So, this is the rate at which the floating leg will pay at t equal to 1.25. The fixed leg will obviously pay at the same 8% per annum, that is 4% for the semi-annual period. So, this is the fixed leg payment, and this is the floating leg payment, which is worked out at this rate 12.102%. The difference is this much, it is discounted at 11% CC, continuous compounding, and we arrive at this. The aggregate value of the swap turns out to be this, which in fact coincides with the value that we have worked out earlier, minus 4.267. That is precisely the value that we have worked out earlier. So, these are the two approaches that can be used for calculating the value of a interest rate swap. One, you follow the prescription that interest rate swap can be considered as a fixed rate bond and a floating rate bond, value them separately and calculate the difference in value. And the other is when you assume that the forward rates that are implied by the spectrum of spot rates prevailing as of today, as on the date on which the valuation is carried out, are actually realized, and LIBOR or the floating rate is fixed in accordance with these forward rates, and thereafter you work out the value. Thank you. We will continue after the break.